Welcome everybody to another lesson. Today we are going to talk about simple and compound interest. So I'm sure most of you have also heard of the term interest. Well, what is it? It's on savings accounts and investments and things like that. Interest is extra money you can earn over time just for investing the money. If it's on a loan, it's an additional amount of money you pay on top of a loan. And many companies charge interest for loans. So I have the formula here just for simple interest. If, let's say, I put X amount of money in the bank for a year and it has X percent of interest, that's how much interest I'll have at the end of the year. And then to get the total amount of money I'm going to have, it's going to be the principal, which is what I put into the account, plus the interest I got. So let's start with our first problem here. Alright. So let's see. I put $200 into a savings account with 8% interest for 1 year. How much money will I have in 1 year? Alright, so let's see. Let's say hypothetically I put $200 into a savings account with 8% interest for 1 year. How much money will I have in 1 year? So, first thing we want to do is find the interest. To do that, this is going to be a simple interest. So the interest is going to be, in this case, we don't know what that is. The capital I for interest. P means the principal. The I equals PRT. P is the principal, which means that's the money you put in. So that would be $200. $200 is the principal. The R, of course, is your rate, which is 8%. And then the T, the time in years, times 1. Well, we know anything times 1 is itself, so we don't even got to consider the 1. So now all you got to do is just kind of plug and play. We know that, to simplify this, we know that the 8% is 0.08 as a decimal. So when you go to stick this into your calculator, that's what you'll get, is you'll have 200 times 0.08. Let's go to the calculator. Get $16. I'll get a grand total of $16 for interest. Alright, so I found my interest to be $16. We've only answered one part of the question. Now the total amount of money I'm going to have after that time period is going to be the principal plus the interest. So let's see. We'll let T be the total amount. So we have the total amount is the principal, which will be that $200. That's what I put in, plus the interest. The interest we found to be $16. Add those together, 200 plus 16 is $216. Alright, so after a year, if I let the money sit in the account and don't touch it, I'll have $216. But with a lot of savings accounts, that some savings accounts you can touch your money anytime. Your average savings account has less than 0.1% for interest. This is probably more of a higher yield savings account. There may be penalties for withdrawing earlier than the time period you agreed upon with the bank. So, and again, I am not a financial expert by any means. If you want to know how to save more money, how to deal with investments, anything like that, I would definitely talk to a financial advisor of some sort, or talk to your bank, talk to investment brokers. They can lead you in the right direction, but I'm just here to demonstrate another practical, useful application. But that's the first problem. We will we got some more examples here. All right. So let's see what this problem is. I put in $4,300 into a savings account with 10.56% interest. How much money will I have in 3 months? How much money will I have in 3 months? So, I put in $4,300 into a savings account with 10.56% interest. How much money will I have in only 3 months? So, again, what you're going to want to do here is, first thing, figure out what your interest is. So the interest in this case, of course, is equal to the principal, which that principal is at $4,300. And the rate for this is 10.56%. Times the time. So we only want 3 months. Well, the T is usually given in years. The T, the time, which 12 months out of 12 months would be 1. We want to know what it is in 3 months. So 3 out of 12 months, we would figure out your T is going to be equal to 3 out of 12. Which, if you reduce that to you reduce the fraction, it'll give you 1/4. So we got to figure out what that is times 1/4. All right. So now, of course, with this interest, we know that 10.56% as a decimal is going to be 0.1056. We know a quarter as a decimal is 0.25. So now all we got to do is plug this into our handy dandy calculator. Make sure you guys are seeing this. Okay, good. Very good. I just wanted to make sure. Alright, so let's see. I'll take that $4,300 principal I put in times the percent, which is, as a decimal, 0.1056, times that 0.25 for the time. So the interest comes out to be $113.52. And of course, that's only in a matter of 3 months and a quarter of a year. So I found my interest to be $113.52. What I now need to do is find out what's the total amount of money I'm going to get. The total amount of money, again, the principal, which is going to be $4,300, plus the interest, which we determined to be the $113.52. So if you add 4,300 plus 113.52, you'll end up getting 4,400. See, $4,413.52. So at the end of 3 months, my total amount of money that that account's going to yield for me is $4,413.52. Not too bad. That's not a bad deal for an account. Just put it in there for 3 months, don't touch it, and I'll have over $100 more. It's probably faster than I could save money myself, so that's not a bad deal. But I got 3 more examples here for simple interest. Okay, what's this problem here? I'm gonna get my marker ready. Alright, now I wish I had this kind of money to put in, but I don't. I put in... Why would I say in? I just say I put... Let's see, I put $100,000 into a savings account with 8 7/8% interest. How much money would I have in 1 year? Alright, so I put in $100,000 into a savings account with 8 7/8% interest. How much money would I have in 1 year? So, again, we want to find out what is that interest. That interest is going to be, in this case, it's going to be the principal, which would be $100,000, which I'd have nowhere near $100,000, let me tell you. If you have that much, please be sure to give me a call. I will gladly help share that with you. Alright, so the principal of $100,000 times the rate, which is 8 7/8%, times T, which is 1 year. So the times 1 will be whatever that is. It'll be itself, so we don't even have to worry about the 1 anymore. Okay, well, it would help if we convert that 8 7/8 into a decimal for a percent. So we'll still have the 100,000. Now 8 7/8 as a decimal is going to be 8.875%. That'd be 8.875%. Times 1 I'm not even going to worry about. Now we can convert that 8.875% into a decimal so we can plug this into our calculator. So still we have the $100,000 principal times 8.875 as a decimal is 0.08875. So now all we gotta do is just plug this into the calculator and we'll get our interest. Let's figure this out. 100,000 times 0.08875. That would give you $8,875. That's your interest, $8,875. Now, of course, we just found the interest after a year. We want to find the total amount of money I'm going to get. So the total amount of money is going to be the principal, which is what I put in, the $100,000, plus the interest, which we determined was $8,875. So if I add those two together, the total amount of money I should end up coming up with is $108,875. That's a good way to save $8,000 and have $8,000 more dollars in your account after a year, because who on average is going to save $8,000? Not many people. If I had that kind of money, that's probably what I would do. But so yeah, the total amount I'll get for a year is $108,875. All right. So we got two more for simple interest. Then we're going to go on to compound interest. And the simple and compound interest will definitely tie into tomorrow, the next lesson rather. It probably will be tomorrow. It may or may not be, depending upon what happens. The other day, when I said this was the last lesson on percentages, I was wrong. I actually saw something else about credit cards and loans, which I thought would be a good lesson after this. We will talk about credit cards and loans for the last lesson of the percent unit, and then we'll be off of that. But let's look at the next problem here. All right. We've already, you know what? Let's actually do something different. Let's skip that one example because it's pretty much identical to what we just done. Let's do this instead. Let's see. Copy Pics Incorporated borrows $10,000 at 9% for 60 days. All right. Find the total amount of money to be paid after 60 days. Okay, so we have this company, Copy Pics Incorporated, borrows $10,000 at 9% for 60 days. Find the total amount of money to be paid after 60 days. So, again, now when you have loans, a lot of loans also follow the simple interest principle. But that's interest they're assessing against you as the borrower that you're going to end up paying to them. So, first thing you want to do, of course, find out your interest rate. The interest is going to be equal to P, the principal. The principal in this case is $10,000. So that's $10,000 times R, the rate, which is 9%, times T, the time in years. Well, if it were a whole year, you'd have 365 out of 365 days. The time in this case is going to be 60 out of 365 days. So the time you're going to put here is going to be 60 out of 365. Because they're only doing it for 60 days out of the year, if that makes sense. So, why I set the marker down? Gosh, okay. So that interest, of course, still have $10,000. Then you have the 9%, which as a decimal we know is 0.09. Then we have that times 60 out of 365. Let me see if I can get a nice decimal for that. I can't. It's not nice. So we're going to have to plug that into our calculator. Alright, so we can go and plug this into our calculator, but when you plug something like that into your calculator, make sure you use parentheses. So make sure you're using parentheses, because the calculator will be able to separate stuff pretty well if you use parentheses. Alright, so these two multiply. 10,000 times 0.09 gives me 900. I need to do 900 times, in parentheses, 60 divided by 365. Which gives me approximately, it'll give me approximately, as a result, if you round to the nearest hundredth, which would give you the nearest cent, as approximately equal to 100, if I can write, not get dyslexic, $147.95. So yeah, that rounds to approximately $147.95 if you round to the nearest cent on your calculator. Alright, now what's the total amount I'm going to end up paying them? Let's write it with a different color. That's the total amount I end up paying them. Okay, so the total amount is going to be that principal, which is $10,000. Because I got to pay back the full $10,000, plus there's interest. Plus that $147.95 in interest. So it looks like my total cost, if I add the $10,147.95, I'll end up paying them $10,147.95. That's what I would end up owing the loan company after 60 days. $10,147.95. Alright. So I think we've seen enough for simple interest here. Now we're going to talk about compound interest. Yeah, simple interest obviously is pretty easy. Alright. Well, let's talk about what compound interest is now. Let's see. Compound interest. All right, so the formula. So what is compound interest? Compound interest is when you have interest assessed on top of interest. So these are good examples of those are specialized savings accounts such as CDs. They have compound interest and they can pay real well. But of course, if you withdraw early from a CD and try to do that, there's a huge penalty. Sometimes it's about 50% of the principal, about what you put in. So it's definitely, if you're going to invest in a CD at a bank, make sure you are committed to it for that time period and aren't going to need that money. But compound interest, that interest is equal to the principal times, in parentheses, 1 plus that rate over the number of compoundings to the power of the number of compoundings times the time in years. That's compound interest. And N is the number of compoundings. Okay, so let's start with an example here. I had 23, right? Okay, let's see. I invest $20,000 so I invest $20,000 into an account seven and 5/8 with 7 5/8% interest compounded once a year. How much money will I have after 25 years? So how much? All right, I invest $20,000 into an account with 7 5/8% interest, compounded once a year. How much money will I have after 25 years? So, again, what you want to do, find your interest. But when it's compound interest, it's a different formula. The formula for compound interest is equal to the principal times the quantity of 1 plus the rate over the number of compoundings. That quantity to the exponent of NT, which is the number of compoundings, and the T, the time in years. So the interest in this case is going to be the principal, which would be $20,000. 20,000, right? Times the quantity of 1 plus what's that rate? 7 5/8. Let's figure out what 7 5/8 is as a decimal. Let's do that on the side. 7 5/8 I know as a decimal is equal to 7.625. So as a decimal, that's going to be 0.07625. Alright, so that's the rate is 7 5/8%, which is 7.625%. which is equal as a decimal 0.07625. So let's write the rate as a decimal of 0.07625 over n, the number of compoundings per year. It's just once. There's only one compounding a year. Then to the power of the number of compoundings per year, which is 1, times the time t in years, 25. Okay. So now let's go through and simplify this. You still have your $20,000 principal. Well, inside the parentheses, let's work in there, okay? That's 0.07625 divided by 1. That's still 0.7. That's still 1 plus 0.07625. Now let's deal with the exponents. 1 times 25, that's just going to be to the 25th power. So you'll have this expression to the 25th power. So now, of course, we have $20,000 times, what is 1 plus 0.07625? That's going to be 1.07625 to the 25th power. Alright, which, now we have parentheses and exponents. We need to go ahead and put this into our calculator. Of course, order of operations, let's do the exponents first. 1.07625. You would use a little caret symbol, like a little pointy hat symbol, to do exponents in the calculator. Which, yeah, it's 6 point something. It's not a pretty number. So we'll take that, then you'll multiply that by 20,000. Wow. So the total, it would round to approximately, for the interest, it's going to be approximately equal to $125,562.26. Alright, so again, the interest, when you put all this into the calculator, it rounds to approximately $125,562.26. That's just for your interest, mind you. We have to deal with the total amount of money that I'm going to be looking at here. So the total amount still hasn't changed for that formula. It's the principal of $20,000 that I put in, plus the interest, which we determined to be $125,562.26. Adding those together, make sure you all could see it still. Okay, very good. Add those together, you'll end up getting a total of $145,562.26. So what started out as putting an investment of $20,000 into his account and into my account 25 years ago has now turned into $145,562.26. Not bad. All right. I do have more examples here. I got 3 more problems and that'll be it for the lesson. Alright, I think I have a problem like it here. Oh, even better. I invest $100,000. Keep dreaming, right? I invest $100,000 into an account with 8 7/8% interest compounded. This is still yearly. Compounded once per year. How much money will I have after 30 years? Alright, so I invest $100,000 into an account with 8 7/8% interest. That should be interest. Well, we'll just know it says interest. Compounded once per year. How much money will I have after 30 years? So, since again it's telling you, the problem's telling you the interest compounds, you're going to use the compound interest formula. So your interest, of course, is I is equal to the principal, which I have is $100,000. That's 100,000 times the quantity of 1 plus, we want to find that rate, the R. Let's work that out on the side. The 8 7/8%. As a decimal, 8 7/8 is going to be 8.875%. Not as a decimal. Well, I mean, yeah, converting the fraction to a decimal. Converting the whole percent to a decimal, 0.08875. Alright, so that rate as a decimal is 0.0875. Over n, the number of compoundings per year is just once, so that would be over 1. And then that quantity raised to the nt power. The n, the number of compoundings, that's just 1. The time, well, that's 30 years. 1 times 30, so that's 30 years. Alright, now let's simplify this expression a bit here. We still have the $100,000. Now, that 0.875, 0.087, I skipped an 8, didn't I? Yes, I did. Hold on, let me make that right, because I'm going to get a completely different result than what I want. 0.8875 divided by 1 is itself, so you'll have 1 plus 0.08875. If you deal with the exponents next, you'll have 1 times 30 for your exponent. Well, that's just 30. So this is going to be raised to the 30th power. Okay? So now I'll take that course. We'll simplify this more. We have $100,000. Now we deal with what's in the parentheses. This is why order of operations is so important, because when you solve in applied problems like this, it can get a little bit crazy. Do what's in parentheses, the 1 plus 0.08875. You're going to get an answer of 1.08875. You're going to take that, raise that to the 30th power. Now it's just a matter of putting it in your calculator, and we will get an approximate number for the interest. So let's go ahead and do that. Alright, so deal with your exponent first. That 1.08875 to the 30th power is not a pretty number. Then take that, what you got for that, multiply it by 100,000. you're going to get a real pretty number of 1,281,873 and 12 cents. So that interest, you already have over $1 million in interest. But we want to figure out the total price. So the total price is going to be equal to the principal, what you put in, which is $100,000, right? Okay, so $100,000 plus the interest, which we have determined to be $1,281,873.12. Now we'll just add these together, you'll get what you're going to have in 30 years. So that would be a total of $1,381,873.12. So I go in investing $100,000 30 years ago, I come out 30 years later, I'm a millionaire. And I wish that's how it worked in real life, but well, I mean, these accounts do work that way in real life. I'm just saying for me, I wish I was a millionaire. But, and by the way, if any of you ever win the lottery, please be sure to contact me. Please be sure to do that. Alright, got two more. What we got here? Pick up the black marker so I can write the problem. There we go. 28. Alright, 28. I invest $40,000 into an account with 7.7% interest, compounded. The problem reads semi-annually, which would mean twice a year. Compounded twice per year. How much money will I have in 4 years? Alright, so I invest $40,000 into an account with 7.7% interest, compounded twice per year. How much money will I have in 4 years? So, again, what you're going to want to do is find your interest formula, which is that I. That's equal to P the principal, which that principal is $40,000. Alright, times the quantity of 1 plus that rate of 7.7%. It's going to help us if we figure out on the side what is that 7.7% as a decimal. That's going to be 0.077. That'd be 0.077 as a decimal. Divided by the number of compoundings, well, that's 2. Suddenly this isn't a simple anymore. We're going to have fun putting this into the calculator. To the power of NT, which is, N is the number of compoundings, 2, times the time T in years, which is 4. Alright, now we got to simplify this for the interest. Of course, the 40,000 still stands. And then we'll have 1 plus, let's figure out what 0.77 divided by 2 is. That shouldn't be too bad of a decimal. 0.077 divided by 2. I didn't think it was that bad. 0.0385 as a decimal. That's what 0.077 divided by 2 is 0.0385. Then we need to figure out to the 2 times 4th power. Well, 2 times 4, that's 8. This is going to be to the 8th power. Alright, let's go ahead and simplify this some more. You'll still have the principal of $40,000. Then, of course, let's work out what's in parentheses. 1 plus 0.0385, that's 1.0385. That's to the 8th power. Now we need to figure out what we're going to have for interest. It'll definitely be a decimal approximation to the nearest cent. So first, let's stick that 1.0385 to the 8th power in the calculator. As I figured, not a pretty number. Then take that result, multiply that by 40,000. You get, oh wow, this is pretty cool. Just for the interest alone, you'll end up having $54,114.29. So you've made more than double already in interest. The interest alone is $54,114.29 after 4 years. But we want to find the total amount of money you're going to see after 4 years. Okay? So the total amount of money is going to be equal to that principal, $40,000, right? Plus what we came up with in interest, which was that $54,114.29. So you add those two together. In 4 years, you'll have a total of $94,114.29. So you've more than doubled what you've made total in 4 years. That's quite impressive. All right, I got one more problem here. One more problem, and then we're done with the lesson. But this lesson's useful because it's going to tie into the next lesson's topic again, which is going to be credit cards and loans. And I feel honestly the credit cards and loans lesson may be one of the most important lessons I ever do. I mean, if I'm being honest with you here. Because so many people, especially younger people, don't understand how credit cards work and how much trouble you can get into with them. Alright, let's see here. For the final one, I invest $100,000 into an account with 8 7/8% interest compounded twice per year. How much money will I have in 30 years? Alright, so I invest $100,000 into an account with 8 7/8% interest compounded twice per year. How much money will I have in 30 years? So I'm going to put this money in the bank. I'm not going to touch it for 30 years. Well, again, we want to figure out what is the interest. So I equals the principal, P, right, times $100,000 times the quantity of 1 plus that rate, 8 7/8%. Let's work that out on the side. 8 7/8%. If we convert the 7/8 into a decimal, just a 7/8, you'll have 8.875%. Convert the whole percent to a decimal, you'll have 0.08875. That would be your decimal, 0.08875. Because the next component is your rate, you'll want to have that as a decimal already in here. Just for space saver over here, that's why I'm converting it to a decimal before I stick that into the equation. It'll save me some space over here so you can all see the results. So it's that rate, 1 plus that rate, which we converted to a decimal, over n, the number of compoundings per year. Well, that'd be 2 compoundings a year. Then we have that raised to the nt power. The n is the number of compoundings per year, which would be 2, times the time. Well, that's t, 30 years. Time in years is t, 30. Okay. Now we're going to go ahead, we're going to simplify this sum. So we'll have 100,000, right? Times 1 plus, we're going to have fun sticking this into the calculator. We got it. Let's stick that 0.08875. Let's divide that by 2. You get 0.044375. If you divide the rate by 2, you get 0.044375. Okay, now we need to figure out what our exponent's going to be. We have 2 times 30, that's going to be 60. So this will be raised to the 60th power. Okay, now let's take care of what's in parentheses. Of course, we have the $100,000 on the outside times, what is in parentheses here? 1 plus 0.044375. That'll give us 1.044375. That whole thing will be raised to the 60th power. I think you're going to have an astronomical amount in interest alone. So, of course, according to the rules of operations, let's do the exponent first. So you'll have 1.044375 to the 60th power. I didn't think it was a pretty number. Times 100,000. So for interest, you get approximately, just in interest alone, you'll have $1,353,281.15. Alright, so yeah. You'll have approximately, just in the interest alone, $1,353,281.15. But we want to figure out what is the total cost I'm going to get. Well, what's the total amount of money I'll see after that 30 years? Well, that's going to be your principal, which was $100,000, plus your interest. The interest, well, in this case, was $1,353,000. $1,353,281.15. For a grand total, putting the finishing touches on, you'll have $1,453,281.15. $281.15 after 30 years. So yeah, if you have $100,000 to invest, you might want to think about investing it into a CD or some other account that has a high interest rate yield. You could be a millionaire. If you start when you're young, put it into an account when you're older, you'll be a millionaire. You can retire comfortably. But yeah, that's really all I have for this lesson. So the next lesson, again, is going to be about credit cards and loans. I really feel that may be my most important lesson. I'll share a personal story with you about some heartache I went through with some credit cards and stuff on the next lesson. So stay tuned for that. I hope everybody has a good night and take care.